So good morning. Today we have the pleasure of hosting Jim Moreland. Am I correct?
That's
it?
okay. Absolutely.
Who graduated with a bachelor's degree in mechanical engineering from this department in 1988. Went on to get a master's degree and a PhD. Long career, so I'll let you talk about that. So welcome and thank you for taking the time and coming and talking to students. Can you tell us a little bit about what you do? And I know that you went from working for the government now in the private sector. Kind of briefly tell us a little bit what you do and what it entails.
Okay. So yeah, after I graduated in 1988, I went directly in the government to be a federal civilian servant as a mechanical engineer. In fact, I went into the naval warfare centers where you really truly get to design, develop things like weapons, projectiles, sensors, radars, combat systems, really things that go on. Think of your destroyers out there today, your big gray hull destroyers, your cruisers, your aircraft carriers, your submarines. For the most part, that's what I was designing and building those systems to go on in that time. So I spent 32 years in the government. I went from being an engineer doing that type of work where I was designing and things like computer-aided design and really watching it through the build and development, and then the transition of it to what we say the war fighters or the battle groups into these big platforms. As part of that, I also put a big emphasis on continuing education, right? So I left with my bachelor's degree, but I continued to work on my advanced degrees as I worked for the federal government. And the big benefit for that is, for the most part, they will pay for that. You just have to do it on your own time in the evening. So yes, it adds a lot more to your schedule, but it's being paid for because they look at that as a huge benefit in advancing your abilities, your knowledge in different disciplines. So after that 32 years, it ended in my last 5 being a senior executive at the Office of Secretary of Defense, where I was the Director of Naval Warfare, so in charge of a portfolio of about $66 billion of all the systems of the Navy that were being run through the defense budget. And then for a couple years, I was the Deputy Assistant Secretary of Defense for Tactical Warfare Systems. That's all the defense programs for any of the military services that come through OSD. About $200 and some billion portfolio for all of that. So it was a very interesting career, going from an engineer all the way up to a senior executive and handling that type of responsibility and leadership, but very fun. After retiring in March 2020, after 32 years in government service, I, in May 2020, signed on with Raytheon Technologies after talking to many of the bigs who you will find out will come after you for what you have done in the past, what your experiences are, the networks you've built up. Most of these companies want that experience. So I went there, I landed as a executive leader there, and right now sit as the Vice President for Mission Engineering and Integration within the Raytheon Strategic Business Unit, and in particular I'm in the Air and Space Defense Systems SSBU we call it, or Sub-Strategic Business Unit.
So who would be interested in pursuing a career path like yours, at least initially?
Yeah. I think any scientist and engineer, if you're involved in national defense, the security of our nation, how do we deter aggression around the world and keep the bad adversarial players from doing bad things against human mankind, you'll want to pursue the direction I went, which was the Department of Defense. Not that there's not other places you can go, but that's where I started my career. I don't know if I would do it over again, because I get to things that the adversarials try to do. Let's take Ukraine for an example. Things that Russia try to shoot at Ukraine that are pretty advanced weapons. We're putting the defending systems in place in the Patriot that's taking all that out, right? So we're leveling the playing ground for Ukraine to fight one-on-one, because we're taking out all that advanced stuff that Russia's doing against them and leveling the playing ground as much as we can. So I love that, because it's a hard challenge, but I love challenge, and you get to put the solution or design the solution, build it, and see the end state when it gets fielded and what it does. Right. So right now the Patriots, I think about greater than 95% probability of kill on anything that Russia's shooting at Ukraine, which is a pretty.
They're lucky to have them.
Pretty good, yeah,
Absolutely.
yeah. Yes.
How would you say your degree in mechanical engineering helped you, again, at the beginning?
Yeah, so the nature of mechanical engineering to me, and I thought about this before I entered it when I was coming to Maryland, is really built in as a multidisciplinary engineering discipline, I think, right? Think of electromechanical devices. When I took mechanical engineering, I had to take a certain amount of electrical classes because if I was going to build an electromechanical device, I had to bring those two disciplines together to make that happen. I really like that. Honestly, as we do this interview, I started off as a double E here. And when I took the first class, although I did well in it, I'm like, but Mike, I can't see the electrons moving. I can't really feel what this is doing, right? So I right away switched to mechanical because it was more of something I could see. I mean, machine design, I can see the machine working and other aspects and what the control system's doing. So it was just a much better fit for what I wanted out of engineering. The focus on the integration of components and systems as they come together to create a capability. Mechanical engineering is more about that than some of the other disciplines, I feel. What was some of the classes that I'll point out that I took that really put a lot of focus on this integration piece? Statics, dynamics, those are some of your earlier classes. Mm-hmm. Robotics. When I did robotics here, I had to look at the application of the robotic arm, the visual camera that's seeing the things to tell the arm where to go, a bunch of pieces coming together to form a capability in the robotic system. So
that's basically what you deal with now. It's many systems integrate and have a platform.
Correct. Yeah. In fact, our nation's really gone that way. In the day, you could say we had more monolithic single systems that would give you a capability. Now we've really moved to distributed, many heterogeneous systems working together to give you that capability. In fact, in the military, there is no mission today where we use one system to execute that mission. It's always multi-systems, multi-sensors, multi-weapons, multi-platforms, working together as a system of systems to execute a mission. And to me, that's exciting. It sounds very complex. It is. But when you have a team of experts that come together and do their pieces and we integrate the pieces, the outcome, the capability that you field is astonishing.
Sure.
Right? It's really...
So other than the technical knowledge you acquired during your studies here, what other skills or attributes helped you, things that you did not take in classes,
right,
that you found were important in your early career?
So yeah, above and beyond the strong curriculum, I was part of the cooperative education program here at Maryland. I would push anybody in that direction. Yes, it had some additional time to getting your degree in 4 years. I was here from 82 to 88, mainly because I co-opted certain semesters where I took off school. So not only did I earn money, but I got real practical experience applying theory to real things. And I co-opted a place called MPR Associates. So let me tell you the background of that. The MPR stands for something. M stands for Mandel, P is for Pandolf, and R is for Rockwell. The three chief scientists for Admiral Rickover when he started naval reactors, nuclear energy as a propulsion within the submarine community. So to have them as mentors, although they were a little bit up in age, was tremendous for me. So I got not only that, but doing the practical work on submarines and then coal power, nuclear power plants. That was what they specialized in. So not only did that help pay my bills, because I got paid pretty well to do that, but when I left Maryland, I now had a resume full of real experiences that was very attractive to a lot of not only companies, but the federal government. And I chose to go what was more stable at the time, I felt, which was the federal government.
Very interesting. Nowadays, not too many students go that route. but I don't have an exact number, but I would say the majority of our students at least do at least 2 internships during summers.
Okay.
Because hitting the job market with no experience usually is not advised. So we do encourage them. But some take advantage of the co-op system, which I think is great.
Yeah.
You know, what is another year in a lifetime? It's an epsilon, it's nothing. But as you said, the opportunities that are going to open up later, the experience you're going to acquire is just tremendous. It's
Completely agree. If I could do it all over again, I would follow that path again.
Absolutely, yeah.
Right? It opened up a lot of doors.
How many people, I'm not going to say how many people were for Raytheon, but in your division or that you work with?
So,
A lot.
yeah, so let me just talk some general numbers. First of all, Raytheon Technologies is a big company. It's about 185,000 employees across the world. And I wrote down some of these numbers. Last year, $26.3 billion of work, 28,000 engineers, 55,000 employees, 58 countries. If you didn't, well, sorry, let me go back. Our Raytheon Technologies, 185,000. That's the big company. It's made up of 3 strategic business units: Raytheon, Pratt & Whitney, and Collins Aerospace. So let me drill down now, because I sit in Raytheon. Raytheon is where it was the 26.3 billion. So this is Raytheon alone, not including Pratt & Whitney and Collins. Raytheon also has 28,000 engineers, 55,000 employees, is in 58 countries. If I drill down even further, the sub-strategic business unit that I belong to is Air and Space Defense Systems under Raytheon. 7.6 billion, 29 customers, 31 countries, 12,000 employees. And we're the biggest now sub-strategic business unit at Raytheon, this ASDS. What used to be air power, we just combined space, air power, and strategic missile defense together as one, and that's ASDS. Wow. So a lot of individuals, right, that I have the opportunity to deal with on a regular basis, and because I'm heavily involved in multi-mission, multi-warfighting domain, which means naval, air, space, cyber. How do you bring that all together to fight it as a system of systems? I have to deal with many countries, many individuals across all the business units, and I like it. It's sometimes it's tough to do because you don't know in what pockets the real interesting and critical work's being done. It's almost like you got to herd cats a little bit and go dig it out, right? Because they are sometimes they're just so busy they don't necessarily share in an automated way. You have to go pull it from them, but all good.
How is diversity viewed?
Yeah,
at
so
Raytheon?
diversity is a big deal at Raytheon, right? All the way up at our corporate level, at RTX level, we have diversity, equality, and inclusion, and it's a initiative at the highest levels. It's also pushed down as a goal every year, and it's pushed down to every one of the business units to pay attention to. But the one thing I'll throw out with diversity, because I want everybody to kind of capture this. Diversity, usually when we really think of nationality, ethnicity, race. Let me throw a couple other things to keep in mind, because I think these are very important. Your experiences, they're diverse in nature. They're very important to get different perspectives on a problem. Absolutely. And on the solution of that problem. The disciplines you bring, mechanical engineer, systems engineer, electrical engineer, those disciplines and the diversity in those is also very important. So when you think of diversity, don't just think of the nationality, ethnicity, and race, which is important, but think about these other things that you're bringing to the table to show the different perspectives, right? Very important to capture.
Well, once again, thank you very much. We really appreciate your taking the time, and we look forward to your presentation.
Okay.
Thank you.
Thank you.